All right, so here we've got a problem now, or not a problem, but like a series of relationships that deal with the derivative and its parent, basically its parent function, the function that the derivative comes from, and the graphs. And some of the things that we can get from this, there's a lot that we can get from this, and we're going to spend a lot of time later comparing the graphs of a function and its derivative. But let's just look at some basic things right now. So here we've got a graph, this first graph in red, and it's a derivative, or I'm sorry, it's a function, f of x, and we're going to notice that here the y values are increasing, which means that if you take a derivative, you're finding the slope of a tangent line. And so right here, all these slopes right here are all positive, okay? And then what happens? We get to this point right here, this max point, and once we get to that max point and we start to come down, all the slopes become negative all the way down to this guy. So now here we've got a negative slope. And then what happens? They all take off again and we go up and we have the slopes all positive. Well, the relationship between the function and its derivative is this. Everywhere that the slopes are positive, the derivative has y coordinates that are positive. So let's look at the next guy. I've got all these positive slope from here to here, positive slope from here to here, right? So guess what? Positive y values. And where do my y values change? Somewhere really close to 2, like right around this area right here. Well, looky there. Look where our derivative crosses the x-axis. Right at that point that our original function had a maximum. And then see how we've got the negative slopes? The negative slopes then step in right there. See those negative slopes right here for this little section? From about 2 to almost 0, we're negative. Well, look, here's that close about 2 place. Here's that almost 0 place. And look at all the y values. All those y values are negative. Negative slope, negative slope, negative y value. And then when we go back over here to the back to positive again, what do we do with our derivative? We cross the x-axis and now it's positive. And so that's the relationship that you have. If your function is increasing with y's, it's positive y coordinates on the derivative. And here we can see both of them together. And I'll just step over real quick. Here's that increasing positive y value behavior, and look where it changes. Look what's going on. The derivative is crossing from positive values to negative, right there. And then when we make that change and we get up to and we start having negative slope, once we get negative slope, those y values right here. Look at the y values on your derivative, all negative, until we cross back over again and our function starts to increase, and so does our derivative. That's the relationship of a derivative and its parent function.